Hi, Grant here again. Today I'm going to talk to you about the different components in every air conditioning system, or most air conditioning systems, and I want to try and lay out how an air conditioning system basically works and what the components are. I'm attempting to get all the components on the screen so you can see them. They're all labeled, as you can see, but I'm not sure how clear this is going to come, so we'll see how that goes. But this is our test board, but it is a very easy way of seeing how all the systems work together. Okay, we have a low pressure side here, and we have a high pressure side here. The system works with a compressor down below that is in the back of the machine, but every compressor usually runs off the belt on the engine itself. So we have two service ports here, a red one, a big one, and a blue one, which is a smaller one, and R134 always uses different sizes to run and to run this air conditioning system. And the connectors use a Schrader valve or a self-closing valve that keep any refrigerant from leaking out. We all know how bad it is to let the refrigerant go into the air system or into the air and damage our ozone layer. And in the case of R134, it damages it gives us greenhouse gases, which damages crops and creates cancer issues and things like this. Okay, so let's start at the compressor. The compressor's down here, and it's kind of hard for me to get onto my camera. So the compressor's down here. It starts compressing. This is a vapor coming out of our evaporator. Evaporator name, right? Okay, so we have a compressor that pumps or compresses and actually pumps the vapor. As it compresses it, it's trying to make it into a liquid. It hasn't quite got into a liquid by this point, but it's very hot vapor that's compressed and more compressed. So this is the high side. It will have a pressure of 150 to, I've seen it up to 325. If the fan's not running, this pressure will be much higher than if the fan is running. The system runs it through this heat exchanger, which is a condenser. And everybody knows what condensation is. What happens when something condenses? It turns from a vapor into a liquid as it goes through the system. This thing will end up with hot pressurized vapor, and we're going to try and get rid of it in front of the rad. This mounts in the front of the rad, and the vapor goes through, and as it goes through, it condenses. So that's a very simple word to understand. It is a condenser. It condenses the vapor into a liquid. By the time that thing comes down to the bottom, it's a liquid, and it comes across over to here to our receiver dryer. Our receiver dryer has desiccant in it and stores a certain amount of refrigerant, but also just dries it out. The desiccant will dry it. It'll move it over to go down this side. This side takes it down to what's called an expansion valve. The expansion valve, you can see it there, has a bulb on it, and it works on pressure and temperature. You see there's a tube that goes up to the top of this thing and measures the temperature of the evaporator, okay? And it actually takes that liquid that we have coming down that copper line and puts it through a fine orifice, which turns the refrigerant into droplets, which is kind of almost a vapor, like a aerosol can if you were spraying it out, or if you crack a propane bottle and you see it come out. It's going to come out in like a mist and go through, and as it's doing that, as it's evaporating, it will be as it's evaporating, it will be taking all the heat out of the cab. The cab, this is mounted inside the cab heater HVAC system, the heater vent air conditioning system, and like I said, this is called the evaporator. The evaporator allows the refrigerant to evaporate, which means it turns from a liquid going through the expansion valve down here and turning into droplets, and as it goes up, it absorbs all that heat and turns it into a gas. As the gas comes out, the gas is going to have picked up all that heat. So the inlet, or the outlet of this evaporator should be much hotter than the inlet. And as this hot gas comes out, we can't put liquid into our compressor. Our compressor will compress gases, but if it tries to compress liquids, it'll blow the head off the compressor or do some damage to the compressor, because it'll bend the reed valves, it'll cause some problems in that compressor, okay? So as it comes through the compressor as a hot vapor, then the compressor again starts to compress it, make it smaller, make it higher pressure, and try to turn it into a liquid, and we're back to the condensation phase. The 4 phases of this system are very simple to remember, okay? One of them is called condensation, condenser, condensation, okay? The other one is evaporate. So when it evaporates, it is the evaporation. It's the evaporation phase of the unit. The compressor is the compression phase of the unit, and then over here is our expansion valve, which is the expansion phase of the system. So our 4 phases are compression, condensation, expansion, and evaporation. And each component does exactly what that phase is called. So an expansion valve over here causes expansion, the evaporator causes evaporation, the compressor causes compression, and the condenser causes condensation. It's a simple system, but the whole thing is how it works together. So I hope this has helped clear up some of the ideas. You can see that the 2 parts of this system are a low pressure system and a high pressure system. The compressor is what splits the 2 of them up, and also the expansion valve splits them up, because the expansion valve takes the high pressure liquid and starts to turn it into a vapor. It turns it into a mist or droplets, and turns it into a low pressure area on the other side of this expansion valve. So that's what causes that to that's where the 2 sides split, okay? So now I know this is very strange because it's not built into a truck, but this is in the cab. The evaporator is in the cab. The condenser is out front of the rad. We blow air through it to remove remove heat from it, to cool it off, and that helps to condense it into a liquid. Okay, this one we blow a fan across in the cab to blow the hot air that's in the cab across it, and actually this will take the heat out of it, even though it's going to be cold, right? It's cooled, and it will remove the heat, and then as it does, it becomes a gas. It evaporates into a gas. It's boiling through here and evaporating into a vapor, and a gas comes out and feeds our compressor again. I hope this has helped you guys, and we'll be putting another one on before too long. Thanks.